Hello and welcome. I'm Mensa Augustine. In this math video tutorial, we'll be solving linear homogeneous second order ordinary differential equations with constant coefficients. So by the end of this math video tutorial, you will be able to solve second order constant coefficient ordinary differential equations whose characteristic equations or auxiliary equations have repeated real roots. So let's see how we do that in a very simple way. Now, let's take this question. If I have y prime prime plus 2y prime plus y equal 0 with this initial condition, y into 0 equal 5 and y prime into 0 equal negative 3. So it means that we are going to have a particular solution as well. Now, the auxiliary equation of this will be m squared plus 2m plus 1 equal 0. And this, if we factorize, we have m squared plus m plus m plus 1 equal 0. We have m into m plus 1 plus 1 into m plus 1 equal 0. Now this gives m plus 1 times m plus 1 equal 0 in a very simple way. So here we have m equal negative 1 twice. So the general solution of this linear homogeneous second order ordinary differential equation with constant coefficient whose characteristic equation have repeated real roots is given by c1 times e power m1 times x plus c2 times x times e power m2 times x. But remember, m1 and m2 are the same. So we can put here mx and here mx. No problem with that. So we write the general equation as y equals c1 e power negative x because m1 is negative 1 plus c2 times x times e power negative x because m2 is also negative 1. So this is the general solution. So once we have these initial conditions, then we can find the particular solution. That is by finding the constant c1 and c2. So let us impose the initial conditions that we have here. So we have y naught equal 5. That is, if x is equal to 0, we have y to be 5. So we write 5 equals c1. If you put 0 here, e power 0 is 1 times c1 is c1. Then if we put 0 here, 0 times c2 times e power 0 will be 0. So we have c1 equals 5. Now, before we put y prime equals 0, we need to differentiate or find the first derivative of the general solution. So how do we find the first derivative of this? We take y prime to be equal to c1 is a constant, so we put c1 down. How do we differentiate e power negative x? Just take the power negative x and differentiate with respect to x. It will give you negative 1. So we multiply negative 1 by c1, and then we multiply the result by the e power negative x. So I hope you've seen how I've done this. Take e power negative x. Take the power, which is negative x. Differentiate negative x with respect to x. You get negative 1. Then multiply it by the original expression to get what we have here. Now we have c2x times e power negative x. So we treat this as a product because we have a linear term x and then the exponent e power negative x. So we differentiate this x with respect to x, we get 1. We multiply it by c2 to get c2. Then multiply it by e power negative x. Wow. Then we put c2 times x down and then differentiate e power negative x. In doing this, we've done it already. We are going to have negative e power negative x. So we multiply this But what we have here to get negative c2x e power negative x in a very simple way. That's good. So we put the initial condition, or we impose the initial condition on this one. We have y prime to be negative 3, so we put here negative 3 equal negative c1. If I put x equals 0, I have e power 0, which is 1. So times negative c1 will give me c1. Then if I put x to be 0, e power 0 will be 1 times c2 will give me plus c2. Here, if I put x equals 0, 0 times everything will be 0. So here I have c1 here to be 5. So this one will give me minus 3 equal minus 5 plus c2. Minus 3 plus 5 equal c2. 2 equal c2. So we write the particular solution y to be equal to c1 is 3, right? C1 is 5 rather. 5 e power negative x plus c2 is 2 times x e power negative x. Okay, here we can bring our y of x in a very simple way. So this is the particular solution, and this is the general solution. Now, try this and then leave your answer at the comment section. If I have the squared y on the x squared minus 10 dy on dx plus 25y equal 0 with the initial condition y naught equal 1 and y prime of 0 equal negative 1. Find the general solution, hence the particular solution. Please, I hope this video finds you well. Can you like, share, comment, and follow for us to build the mathematics community.